Okay, we have here two algebraic proof questions from A-level. The first question says that we've got to prove for all n that's a member of the natural numbers that n squared plus 2 is not divisible by 4. Now, the best way to approach this is to consider two possible cases. Either n is even or n is odd. So what I've done here is I've written out or reminded you what n is. So the natural numbers are the counting numbers, 1, 2, 3, 4, and so on, positive integers. And case 1 is when n is even. And if n is even, then n can be written as 2 times some integer m. Okay, so m is any integer. Double it, I'm going to get one that's even. Okay, now 2m squared plus 2 over 4 is the same as 4m squared over 4 plus 2 over 4, which is m squared plus a half. And clearly that's not an integer, because m squared is an integer. If you add a half, it's not an integer. In case 2, we're going to consider that n is in fact an odd number, and any odd number can be written in the form 2m minus 1. So m is any integer, double it and subtract 1, it's definitely odd. So if we then square that, 2m minus 1 all squared, and then add 2 to it, we get 4m squared minus 4m plus 3. Divide that by 4. We can see that the 4's will cancel here to give us m squared plus m, but then we're left with 3/4. Now, because we know m squared is an integer and m is an integer, 3/4 isn't, therefore the whole thing is not an integer either. So to conclude, there's no natural number n such that n squared plus 2 is divisible by 4. In part 2 of this question, we're told that x is a real number and the value of 3x minus 28 modulus, that's the absolute value, the positive value of that, is greater than or equal to the value of x minus 9. Now what I've done is I've plotted the graphs of those two functions, and you can see that the red line is mostly above the blue line, but there is a short section here where it's below. So we can see what the answer is going to be from that. But what I'm going to do now is show you a thorough way of proving that. So let me just take this out the way. Okay, and this here as well. So what we've got here is that I've started by considering the positive part of this, 3x minus 28, ignoring the modulus signs, setting it greater than x minus 9, and I can see, solving it algebraically, that x has to be greater than 9.5, which is this point here. Okay. Now, if I do the negative of this modulus function and solve that inequality, I end up with minus 4x greater than minus 37. You need to swap the inequality sign round here, because when you multiply by divide by negative 4, this is going to change round. So basically x is less than 9.25, 9 1/4, which is there. Okay, so I now know that there's this little short section where the modulus function goes below the straight line. And what I do is I can therefore say it's sometimes true, and I'm even going to give two examples. So when x is 9, it's true, since that is equal to 1, which is greater than 0. And when x is 9.3, in other words, I'm choosing something down here, okay, where I can see it's not going to work, then I can say it's false, because that is equal to 0.1, which is less than 0.3, which is what you would get if you put 9.3 in there. Okay, so that's a very thorough proof. You would get away with just doing that part there because you're showing that it's true in one case and false in another, supported by that graph as well. Okay, hope that was helpful.